you guys have all seen this. We're all comfortable with force times distance, distance pushing stuff.
Move a kid. That's always fun.
Effort, yeah. So if there's a kid, but
keep it appropriate.
Don't touch the kid, but just move him. Yeah.
You have a lot of examples.
Just say, there's confusing words up there, so just say, we're moving things, okay?
Depending on what.
Yeah, we're trying to move things. So there are 7 types. This is actually debatable, but lever, wheel and axle, pulley, incline plane, wedge, screw, gear. And if you believe that pyramids were made not by aliens but by humans, they would have had to use all of these machines to make them. They've been around for thousands of years, and again, they just help us move things.
Alright, so first we have a lever, which we all know, but basically it's made out of 2 basic parts, a rigid beam and a fulcrum. So if everyone want to get your arm out, we want this rigid, which means, what does rigid mean? Rigid mean strong, or not elastic, right? We can't bend at all. So we have our rigid beam. Now everyone make a fist with your other hand and stick it right in the middle. And then we can actually rotate that rigid beam around that fulcrum. So the fulcrum is just a fixed point that the beam can rotate around.
Sometimes kids will sit there and do this. Hands down.
Alright, so here we have some examples of all 3 classes of levers. We have trebuchet, baseball bat, and a wheelbarrow.
Next we have a wheel and axle. Again, it consists of 2 parts. The only simple machine to have 2 parts, so it's the most complex of all the simple machines. But the wheel and axle are directly connected and they move together. So anything with a handle that you can turn is a wheel and axle. So a steering wheel is an example of a wheel and axle. We have the wheel there because it's easier to turn this. Okay, we have more advantage with this than it is if you were to just actually grab that steering column by itself and try to pinch it and turn it. That wouldn't work very well. Screwdriver, door handle. Who's been to Shields? Woo.
Pulley, which has been around thousands of years. This is the exact same as what we just went over. This is just the intro, so the kids will know what it is at this point. And so here we have some different variations of pulleys. So first we have fixed pulley, where basically we pull down, moves up, no movement of the pulley. We have a movable pulley, combination, pretty much the exact same thing that we just talked about.
Arnie, I'm answering your question right now.
Yeah, no, what I was going to ask is, so in the introduction, and then we come back and we do pulleys. Can we ask them and name them?
Yeah. If you guys have an hour for like a lesson like this, or like the pulleys, or the wheel and axle and lever, make sure you guys quiz them a lot. That'll be like 10-15 minutes of you just quizzing them about types of engineers, what engineers do, types of simple machines. That's a good review, and we'll get them thinking and warmed up. So here we have the exact same examples.
Incline plane. So an incline, a plane can mean 3 things. It can mean normal, like a bagel, like a plain bagel. Okay. Plane can also mean the thing flying. Plane can also mean an extended flat surface, confined to whatever parameters we put on it. So for our purposes, a plane is going to be our arm. Okay. So everyone, arm out is this flat surface. Then we're going to tilt it up. Incline means tilted. Okay. So incline plane, tilted, flat surface. That's all that means. And we use these generally to lift things. Okay. So we'll see some examples of where we might use them. Again, a Ferrari. So tilted flat surface here used to put it in the bed of the truck. The skateboarder probably couldn't jump as high as he does with a quarter pipe there. Okay, so without that ramp, he could not get that high, and because he's moving himself, he could not do that work by himself without an incline plane. And a roller coaster is also an example of an incline plane, just constantly changing.
Okay, next we have a wedge. So if everyone will get your incline plane back up, and now make another one with your other hand, and then put them together. And what shape is that? It's up from here. Try. Mountain. So here we have some examples. So a door stopper, any type of axe or anything that cuts something else is going to be a wedge. So a good general rule with a wedge is anything that splits apart something or holds things together. So holding things together, we have the door stopper, so it's going to hold the door and the floor together so it doesn't move. And then we can see here that it's actually splitting apart that tree. So those are what wedges are used for. We actually have a wedge on our body that we use every day. So what is that, Jordan? Our teeth. Our teeth. Good.
Next we have a screw, which is our flat tilted surface wrapped around a cylinder. So a cylinder is a circle, elongated. So you guys probably have all seen a cylinder. Sometimes if one of us brings in a water bottle, this is a good time to pull it out. Say this is kind of like a cylinder. We wrapped an inclined plane around it. We've seen these on those really cool gumball machines where you put your quarter, push the thing and the gumball comes out. That's an inclined plane. We use these also to lift things, so we'll see some examples here. They can be used as fasteners, like a screw or a bolt, or an Archimedes screw, which is used to lift water. So picture yourself on a slide. You're on one of those twisty slides, and someone holds you there, and the slide itself actually twists. Okay, then you would actually be lifted up. Do we have the GIF here?
Yeah, you guys ready? It's exciting.
This is now exciting.
Oh, look at that. Look at that.
Whoa. Balls. So it's lifted.
And then it starts. Okay.
When does this stop?
Can we watch?
Let's give a round of applause for that.
It gets better. So a gear is a wheel with teeth around its outer rim. So we have a couple pictures right here, and all these little pokey things are called teeth. And we have two different types of gears. We have a driver gear and a driven gear. And the driver gear actually transfers the force that you put into it to the driven gear. And the driven gear is the gear that moves, and it's actually attached to the load. So where have we seen gears before? On a bike, good. So here's some applications. Here's some applications where we actually put our force into the pedals on a bike, which turns the driver gear, and that's outputted in the driven gear, which is attached to the back wheel. We have a rack and pinion gear, where the rack is horizontal, and then the pinion is actually the gear that turns along it. We see linear gears in clocks. Then we have a worm gear here, where we can rotate this, and it'll actually rotate the gear. And then we have a really cool type of gear called the crown gear, and we can see that in hand drills from way back when. Cameron actually has one.
Who actually built this with